Alright, so today is about synthetic division. From here on, Chapter 6 gets a lot easier. It's going to take me a few minutes to get there, but I promise today will be a pretty good section for you once you start seeing how easy this is. A binomial factor, binomial means two terms, is given as x minus a. We know this, going back to last section, x minus 2 or x minus negative 2, which becomes x plus 2 and so on. And so, when it is given like this, a is opposite of what you see in factor. In the 6.1b notes, you were given like x equals negative 3, and you had to write that as x plus 3, right? X minus negative 3 gave you that. If I just give you to you as if given as a, then same. You'll see what I mean as we go through here, what I'm talking about. A is a factor of the polynomial if and only if, when you divide it through, you get 0 as a solution slash remainder when plugged in. Okay. So what I mean by that is, let me plug in, what is A here? A is 3, again because it's the opposite of what you see, and I'm just going to plug 3 in. So I'm going to have negative 2 times 3 cubed plus 15 times 3 squared minus 22 times 3 minus 15. I'm not going to take too much time with the calculations, but this is 27 times negative 2 is negative 54 plus 9 times 15 is 135 minus 66 minus 15, and when you add it all up, guess what you get? 0. So it's asking if it's a factor. Well, the answer here is yes, and the reason is because you got 0 as a remainder. You guys try the other one. Now again, A is negative 3. Plug negative 3 in. If you need a little hint, I'm going to keep going here. Otherwise, pause it now, try it on your own, plug it in and check it. Remember, anytime I plug something in, I need to plug it in parentheses. And now again, I have this all. This means negative 3 times negative 3 times negative 3, which is negative 27. This is negative 3 times negative 3, which is 9, so plus 18, minus 15, plus 12. What I get here when I add it all up is negative 12. You can use your calculator for that. That does not equal 0, so the answer here is no. So simply, the answer to 1 and 2 are yes or no. Okay. Now, we're going to get to synthetic division, but what I want to do one time, and I want to write out the resulting polynomial. We'll see what that means. What I want to do is just one problem with long division, on one problem only, so you can see how difficult it is, and then how easy it's going to be when we start doing it synthetic division-wise. I am going to ask you to do this on one problem on the homework. It is a very easy problem on the homework. Don't make it harder than it is. What we're going to do is we're going to take x plus 3, and we are going to divide it into x cubed plus 2x squared plus 5x plus 12. It's just written from right above here. Okay? And what I want to do is factor in x into x cubed. Well, x goes into x cubed, x squared times, just like in regular division, if I were to take 3 into 1042, I'm randomly picking a number, I would say 3 goes into 10 3 times. And then what would I do next? Well, I multiply the 3 and the 3 to get 9, and I would subtract, right? So I'm going to multiply the x squared through x cubed plus 3x squared, and I'm going to subtract the whole term. When I subtract the whole term, what happens here is it's this minus this and this minus that. So what I'm going to do here is I'm going to just change the sign of both of these and add down. Those will cancel. Negative 1x squared, bring down that 5x squared just like I would do, bring down the 4 and go from there. If I pull an x out of negative 1x squared, it's negative 1x. And again, I'm going to redistribute this. Don't let this be the thing that gets you thrown off for this whole section. It's not this hard after this one. Again, I'm going to minus that whole term, which means I'm going to change both the signs. Now, I won't worry about that. Those will cancel, which we want. This comes down to 8x plus 12, because I got to bring the next term down, just like I would bring the next term down when I do it that way. X divided into 8x is 8. Multiply it through. I'm going to subtract it, so I'm going to take the opposite of both signs, and I get negative 12. So what I get here is a remainder of negative 12. Well, what it wants me to do though is write it out in polynomial form. So what do I have here? I have x squared minus x plus 8. Well, let me come back to this problem, okay? 3 goes into 14 4 times. I would get 12. I'd subtract and get 2, bring down the 2. Goes in there 7 times with 1 left over. Well, if you don't remember, it's the whole number and then it's like a check. It'd be 347 and 1/3. So this is plus negative 12 over what I divided by, x plus 3. And that was given right in the problem anyway. That is my final answer in polynomial form. Okay? Crazy, I know. The rest of it's way easier, I promise. What we're going to do next is called synthetic division. Okay? We're going to do number 6 here using synthetic division. And here's what you need to know. The first thing you need to know is, what does A equal? A equals 5 in this problem, because when it's in factor form, we take the opposite. So I'm going to have 5, and I'm going to put a division sign. I don't need any room above it because I'm not going to put anything above it. That's why it's kind of weird. And what I'm going to write on the inside is the coefficients of the polynomial given. The coefficients are the numbers in front. So 1, because that would be here, negative 5, negative 7, and 25. And then I'm going to draw a line below. But I want to leave some space in here because I'm going to write some numbers. The first step is always this. Bring down the first one. I call it drop it low. Yeah, that'll make some of you giggle. Bring the 1 down, and then what I'm going to do is times these and write that result there, 5. Okay, then all I'm going to do is add down, negative 5 plus 5 is 0. Then I'm going to times these and write that result right there. That's 0. And then add down, negative 7. Then I'm going to times these to get negative 35. And then I'm going to add down and get negative 10. And there is my answer, except it wants me to write out the resulting polynomial. Well, think of what happens. If I divide an x out of x cubed, what am I left with? Well, I'm left with an x squared. Moreover, this is my remainder. This has to be my constant term, my number, then x squared. So it makes sense when I pull an x out of x cubed, I'm left with x squared. And the numbers that are here are just your coefficients. So the answer to this is 1x squared plus 0x, which I'm not going to write, minus 7 plus negative 10 divided by what we're dividing by, which is x minus 5. That is my polynomial. Now I know some of you get it right now. Probably most of you don't yet. So let's look at another example. Okay, I'm going to redo this problem using synthetic division. I know what my A is. My A is negative 3. So I'm going to put that on the outside. I'm going to divide it into 1, 2, 5, 12. Those are my coefficients in this problem, number 5 here. What do I always do first? Drop it low. Multiply to get the next term. Add 2 plus negative 3 is negative 1. Multiply to get the next term, which is 3. Add, bring it down. Multiply to get the next term. Add, bring it down. And then I just say, well, this is remainder, number, x squared. So I write out my polynomial, x squared minus x plus 8 plus negative 12 over, again, what did I divide by? X plus 3. Well, look, that's the exact same answer that I got right there. Okay? Let's keep going. Maybe after you see one more, you'll start to see what this is. It's really as easy as you see it so far. I've got to move this up because I know I made a mistake on the last one where I didn't move it up. I'm going to do number 7 because it works out kind of weird, but I want to show you what it is. Again, what is A? A is 1. So I'm going to put 1 into 1, negative 1, 1, negative 1, 1. Drop it low. Multiply, add. Multiply, add. Multiply, add. Multiply, add. So now again, what if I take x out of x to the 4th? What am I left with? Well, if I take 1x out of here, I'm left with x cubed. So this better be an x cubed function. Now again, I always start with remainder, number, x squared, x cubed. Yep, that makes sense. So I'm going to have 1x cubed plus 1x plus 1 over x minus 1. And that's it. It's as easy as that. What I want you to try now is look at what I've done here, and I want you to try 1, 8, and 2. So 1 and 2, what I mean by that is I want you to go up, back up above, and rewrite what they have way up above. Okay, so I'm going to kind of show you what I mean here. Right here is number 1. So A is 3, whereas in number 2, A is negative 3. Okay, so again, I'm going to put 3 into, what are the terms? Negative 2, 15, negative 22, and negative 15. So I've kind of helped set up number 1, redividing this problem. I also want you to do number 2. Okay, now keep in mind, these numbers are different in number 2. Don't use the same numbers. Okay, and then I want you to try number 8 on your own as well. Try those a minute, press pause, come back and check when you're done. I'm going through these kind of fast. Drop it low, multiply, add. Multiply, add, multiply, add, and look, I get a remainder of 0, which is what I got when I did that problem up above. That's what I need to have. Now, what is my resulting polynomial? Well, remainder number x squared, just going in standard form, negative 2x squared plus 9x plus 5. I don't have a remainder, so I don't need to write it. That's it. Okay, move it up so you can see the rest here. I'm going to do number 2 and number 8. I'm going to set up first. Negative 3 into 1, 2, 5, 12. I'm going to do 4 into 1, negative 5, 5, 7, negative 12. Do these kind of quick. Drop it low, always first. Multiply, add, multiply, add. This is where a lot of you are going to have a 2. We're not subtracting every time. The reason we subtract these two is because they're opposites. But these are the same. So if you had a 2 here, it's because you subtracted that. This is multiply and add those. This is multiply and add those. Then I multiply and add those, and I get negative 12. And here I get x squared plus x plus 8 plus negative 12 over x plus 3. Okay. Now, moving along, drop it low, multiply, add. Multiply, add, multiply, add. Again, if you had a 3 here, you did the same thing I was talking about in the previous problem. I am adding 4 plus 7 to give me 11. Multiply, add, and I get, well, remainder number x squared, x cubed, so I get x cubed minus x squared plus x plus 11 plus 32 over x minus 4. And that is how synthetic division works. Hopefully you tried some of these on your own and you were able to get some. Let's go to the next page to finish up these notes. There isn't a whole lot more. It gets just as easy, if not easier. Okay. All right, let's go up to the top here. I want to use the remainder theorem, so all I need to do is plug 2 in. So if I plug 2 in, I'll show you that way. 3 times 2 cubed minus 4 times 2 squared minus 5 times 2 plus 1. This is 8 times 3 is 24. 4 times 4 is 16. 2 times 5 is 10 plus 1. And I get, well, 8, negative 2, negative 1 as my answer. Something tells me a lot of you are going to make mistakes doing it that way. Guess what? We know that the remainder is the number we get left over when we do it synthetically. So instead, let's just plug 2 in. Again, I'm using 2, not negative 2, because A is given to me. And I'm going to plug it in synthetically. And watch how fast this can go if we know what we're doing. Drop it low, multiply, add, multiply, add, multiply, add. There's my answer. Just like I got there, which probably would have taken you maybe another step besides this. But instead I could just do it synthetically. So let's just do it synthetically for all of them. Let me try the next one. I'm actually going to skip to 11. I'm going to have you guys try 10 and 12. I'm going to go through with negative 3 and divide it into 1, 6, 10, 3. Drop it low, multiply, add, multiply, add, multiply, add. Oh, that one is a factor because I got 0 as my remainder. Try 10 and 12 on your own, please, and come back and check your answers. Drop it low, multiply, add, multiply, add, multiply, add. There's my remainder. Drop it low, multiply, add, multiply, add, multiply, add, multiply. Oops, sorry, that's a 28. And add, and 39. That's it. That's all you gotta do to find the remainder. So if I ask you to use the remainder theorem, that's all you gotta do. Down here, this should be a review. Remember to think of GCF first. This was on the last quiz as well. What is the biggest number I can take out of all of those? Well, I can take a 2 out of those, and I can take at least one x out of all of those. I'm left with x squared, again, because I'm dividing 2x out of all of these. 2's cancel, I take an x out to get x squared. Goes into there 10 times, x coming out of there an x time. Here, the x's cancel, and I get 25. Well, that factors to give me 2x times x and x, minus 5, minus 5. Now, could you write that as 2x times x minus 5 squared? Yep. But if you left it as this, that is also acceptable. Okay? Try number 16. Pause it a minute. Try number 16. The GCF here, I can pull a 2 out of each, but I can also pull a 4 out of each. Can I pull a 6 out of each? No. An 8 out of? No, because I can't pull it. Okay, so just 4x. Pull it out of here. Dividing a 4x, I get 3x squared. Dividing a 4x, I get 5x. Dividing a 4x, I get minus 2. That I can factor into, well, I know this is prime, so 3x and x. I also know 2 is just 1 and 2, so it's either 1, 2 or 2, 1. Be careful. If you had this as 2 and 1, you can get 6 minus 1 to give you 5, but it would not give you the negative 2 because 1 would be negative and 1 would be positive. Okay, 1 needs to be negative, 1 needs to be positive. So actually, I meant that, I had that right. Sorry. If you had 3 and 2 to give you 5, that will give you that if you have plus plus, but plus plus won't give you a minus sign here. So what I need is what I said the first time, is a 1 here to give me 1x, 6x. I need a positive 6 and a negative 1, so I put negative in both. Negative 1, yep. Negative, nope. I need that to be positive. And there is my solution there. Your homework is the next 2 pages. What you'll recognize is they match up almost exactly with what we just got done with. The only difference is when I get to these problems here, it wants me to write out the resulting polynomial. Well, that is just 1 less. So this is x squared plus 2x plus 2 plus negative 13 over x plus 5. Again, when I give you a, the remainder here is the opposite. Same thing here. This would be 2x cubed minus x squared plus 3x plus 7 plus 39 over x minus 4, and so on. That's what it's asking you to do in the homework. It's the only difference from what I just got done and what's actually in the homework. Use your notes, use this video, get the homework done. The other thing is, make sure on number 5 you are using long division. It will come out perfect, I promise. Okay? Try it. All right, have a good day.